I hope the recording has started. Okay, fine. So let us start from what we have uh, finished in the previous page. So jot down all the formula. So it might be helpful for your test or anything, or if you want to remember where we have started and up till now what we have done. And it's actually the easy part. If you, look into the deep calculations, line by line calculations, always it will be more brute force. But once the dust settle down, you can see, and if you can write down all the formulas up till now, whatever you have worked on into one page, so you can clearly see up to some point, okay, we have done so far. So we will take it from here. We'll take it from here and we will see actually what we can talk about this uh, alpha and beta, its eigenvalues for the angular momentum. So let's start for today's talk. Uh, so I'll just put a bar over here. So we have done up to this. So we have seen that if Z is acting on J plus minus this eigenkate, it will raise this thing, and immediately if I say J square, if it is acting on this, it will be the alpha will be coming out. So we can conclude. So we conclude the fact that J plus minus acts on kate alpha beta, does not affect the first quantum number alpha, but it increases, or decreases, both way, the second quantum number beta by 1 unit. So you can clearly see that beta plus minus 1, it's happening. Okay, now this is the place we will take the advantage of this observation, and we will write down that J plus minus acting on alpha beta is some constant which we will find soon into, as alpha plus minus alpha comma beta plus minus 1. So remember, it is similar thing to the raising operator and lowering operator in simple harmonic oscillation. So if J plus is like the raising operator and J minus is like the lowering operator. But in this way, you cannot increase. J plus, if acts on this beta, it will go from beta to beta plus 1. Similarly, the state alpha is not affected. And similarly, J minus acting on this, it will be going to be to beta minus 1 state. But again, alpha is not acting. Now, you cannot do this, I mean, continuously and lowering continuously down or raising continuously up. No, it is not possible. This is the same logic, just like the simple harmonic oscillator. So it has to stop in both ways. So you can think in this way that even if it is the states are like this, it is increasing. Just a minute, yeah, it is increasing like this. It has to go someplace. You have to call that beta max. Beyond that, it cannot go. And similarly, it can go someplace to beta mean, beyond which cannot act on lowering operator. So in this way, it will act J minus. In this way, it will act J plus. So how to see this thing? So let us observe. Remember that this J square is nothing but Jx square plus Jy square plus Jz square. So Z square minus Jz square will be square of this Now this is always strictly positive or zero. So if I calculate the expectation value, that will be the same thing. So let us calculate the expectation value of this object, j square minus jz square on both side. And by the rule, initially you have this, how this operates on this gate. You can get it like this easily. You can get it like this. Uh, h bar square alpha minus beta square greater than or equal to 0, which implies alpha should be greater than beta square. Now beta has a upper limit beta max, so that means there exists some kate alpha beta max which cannot be raised. What I mean by say, since beta has a upper limit, let's call that beta max. We have used this nomenclature here already, so I'm just borrowing that nomenclature, beta max. uh, there exists a eigenkate or eigenfunction, whatever you want to say, which can't be raised. That means if I act on that j plus, which is the raising operator, it should give you 0 in principle. And that is our starting point to have some bound on this number alpha and beta max. So we go to the, oh, okay, I have page over here. So if this is 0, then it can be easily understood that j minus even acting on this, that is also 0. I'm not writing on the next line, you can easily understand. And now I know what is j minus and j plus operator acts on. So you can, that's why this formula I have kept it together so you can easily see it. So j minus j plus, j minus j plus is nothing but from this formula you can bring it on. So if I wanted to calculate j minus j plus acting on this alpha beta max, it would be nothing but j square minus jz square minus h bar jz. Just look into it. J minus j plus. J minus j plus is nothing but the lowering, the lower one. So only the minus symbol will come. The minus symbol has come and it will be acting on this eigenkate. And exactly you can have the answer. So it is nothing but h bar square alpha minus beta max square minus beta max alpha beta max. So from here, what do you get? From here, this is equal to 0. So you can easily get from here alpha is nothing but beta max into beta max plus 1. We'll go to the next page and use the same argument for the lowering. So now I have seen if it happens j plus acts on this, from this argument I came to a bound on this, I came to a formula for alpha in terms of this beta max. Similarly, I wanted to come for a formula in terms of alpha and beta minimum. So by the same logic, I'll not do the calculation. Let me write it by the same calculation, by similar calculation. Let me write by similar calculation. We can show, we can show that j plus j minus acting on alpha beta minimum is nothing but h bar square alpha minus beta minimum square minus beta minimum alpha beta minimum. So which eventually tells you alpha is equal to beta minimum minus 1. Now carefully see, just now we have concluded that alpha is equal to beta max plus 1. So basically we have to solve this equation, and which gives you the reasonable solution. Beta max should be equal to minus beta mean. Now a trivia or fun fact, let me call it a fun fact, is that many of you think that it is a quadratic equation. If I put this two both equal to, this will be quadratic equation, and there will be two solutions. Of course there is two solutions. The other solution is beta minimum should be equal to beta maximum plus 1, which is not possible. Just look into the picture. Minimum Beta minimum, which is down, cannot be certainly greater than the beta maximum. It's unreasonable. So yeah, that's why beta maximum should be minus beta minimum. You have to take this solution. Now, since, let me write it in different color, since beta minimum was reached a finite number by n applications. N application means n time j minus operator applied on that. By n application of j minus on alpha beta max. So beta max is nothing but beta minimum plus n. It follows from there. Now carefully see these two equations I have, so I can easily get what is your beta max. So beta max is nothing but, or you can see twice beta max is nothing but your n. Hence beta max is equal to n by 2, and this is the turning point in this whole game. What is this thing? Hence beta max can be integer or half integer. If n is equal to 4, 6, 2, like this even numbers, it will be an integer. If it is odd numbers, then it will be a half integer. I mean odd multiple of half integer, depending n being even or odd. We have to introduce the conventional what we usually say for beta max. So now at this point we have to introduce the conventional notation. Now what is the conventional notation? It is generally taken as small j as beta max and small m as beta. Sorry, this is equal to beta max. Okay, let me erase this portion. Beta max is also equal to n by 2, which is nothing but n by 2. Yeah. So now remember alpha is equal to beta max into beta plus 1. So alpha we can rewrite it in terms of j into j plus 1. And m lies between minus j to plus j. So m lies in between plus minus j for any particular value of j. Okay. So now j square and jz we can write it in the following notation, and that's why we are going to end it today. J square jm equal to h bar square j into j plus 1 j comma m, and jz jm is nothing but mh jm. Now as an example, I'll do an example in this page itself. so that it will not take j equal to 0, 1 half, 1, 3 by 2 like that, and m goes from minus j minus dot 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 j minus 1 comma j up to that. As an example, that means m has 2j plus 1 values. M has 2j plus 1 values. As an example, if j is equal to odd, so m is equal to, let's say, minus 1, 0, 1. Let me not put a bar over here. Yeah, these three things are there. Similarly, if j is equal to half integer, let's say 5 by 2, then m is equal to minus 5 by 2, minus 3 by 2, minus half, then half, then 3 by 2, then 5 by 2. It is matching. So 2j plus 1, you calculate 2j plus 1, that means 2 into 5 by 2 plus 1. So 6, and you can count it. Value of m 1, 2, 3, 4, 5, 6. And our next job will be to find out this c plus minus, this constant. C plus minus, we have told that constant we will find, and from there we will go for the matrix representation as we have done for the simple harmonic oscillator. We will stop it here. Thank you.